Welcome back to the PFC podcast. The views and opinions you are about to hear are the speakers and do not necessarily reflect those of anyone else. Now on to the podcast.
Welcome back to the PFC podcast. This is Dennis, and today I'm with Patrick, Mason, and Jonathan. How are you guys doing today?
Good. Great, Dennis. Thanks for having us.
Sir. Yeah, appreciate for having us.
Well, the reason why I asked you on the podcast, you guys did a presentation at SOMSA about cadaveric blood and research involved in that. And that's definitely kind of a hot topic that's kind of floating around. And since I didn't get to listen to it, I'm going to use whatever privilege this brings and ask you guys to jump on and explain it to me personally. So I really appreciate it.
Awesome. Thanks, Dennis. So briefly, Pat Walker, I'm a active duty Army trauma surgeon at Walter Reed, and then the program director of the Battlefield Shock Trauma Support Program. It's a translational platform, the Department of Surgery at USU. Let John and Mason introduce themselves as well.
Yep. I'm Mason from Delhi. I'm a first-year general surgery resident at Walter Reed. I did do a lot of research in this space for large-scale combat operations and combat casualty care, trying to look to improve battlefield care for our soldiers.
Jonathan Wong, also a first-year resident at Walter Reed General Surgery. I also graduated from USIS, worked with Dr. Walker in the Battlefield Shock and Organ Support Lab.
Awesome. Well, I appreciate it, you guys. So you're definitely are more spun up than I am about this topic. We did a podcast 207, so it's been a hot minute ago, about what probably could happen. But you guys are actually starting to do the research, the foundational research, I would say, on what actually does happen. So of all the things in LISCO that we are having questions about, I guess, why did you guys pick cadaveric blood?
And thank you for, all the work you do, Dennis, and looking into this. I think, from the, perspective as surgeons or surgeons in training and taking care of those and, put themselves in harm's way. Blood's really our bullets, and, it's what really enables us to do what we do, and the work at the Joint Trauma System and others, looking at how challenged we're going to be in these potential large scale combat operations, to have enough blood to deal with the casualty throughput, the logistic constraints. Walking blood banks have been fantastic in the global war on terror, and I'll let John and Mason, really talk about those. But we just don't have any good answers. There's been a lot of work and interest in blood substitutes, and many promising candidates over the years that have fallen short for a variety of reasons. And there's ongoing work with DARPA now and their F-sharp program that's really exciting. But if we're looking in the kind of the near term horizon, we don't have a lot of good answers. And so, for us, I would say about a year ago, we got really interested. There was a meeting at DARPA, and actually Admiral Via, the Navy Surgeon General, was talking about the potential need to look at cadaveric or deceased donor blood use in mass casualty events, particularly if we're going to look at a place like the Indo-PACOM. At the same time, John and Mason were doing some work in our lab, and we had a conversation, and these guys had really been looking at it, and I just really had some compelling information, and so that abstract, the data that was presented back at SOMSA was really just some exploratory investigational data. We took this is just a couple pigs, but they were at the end of a shock and then Roboa protocol. So we had a balloon in the aorta, And then, essentially ended the experiment and just kept measuring the blood and saw what happened over the course of a couple hours, really 90 minutes. And, what we showed, at least in that data, again, just exploratory, is that there is some clot breakdown, but the blood, it does retain its ability to form clot. The pH drops to about 6.7, but you asked how it compares to normal saline. And normal saline has a pH is somewhere around 5 or 5.5. Normal is going to be 7.4 for us walking around. So, it seems a bit better there. And it I think at least opens up the possibility of what it could be. Red blood cells, of course, are very hard to engineer. The way they hold on to oxygen versus let it go under different conditions, the way they can carry off carbon dioxide and other metabolic waste. I'll let John and Mason speak to a really compelling deep dive they've done into what's been done for cadaveric blood donation or deceased donor blood donation historically, which I think is really interesting as well.
Yeah, I can start off and pass this off to Mason first, so that he can kind of give a little bit of background as to why we looked into this in the first place, along with like a brief discussion on the blood shortages that we might expect moving from coin to Lisco. And then I'll dive in a little bit more into the research that we found on the existing usage of deceased donor blood historically.
Yeah, so over the last 4 or 5 years, maybe even longer than that, we've been kind of making this transition from a coin mindset to more of these large scale combat operations. There's been numerous large peer reviewed publications that have come out in the Journal of Trauma, Military Medicine, etc. How are we looking at the number of casualties we expect in Lisco? And obviously with the war in the Ukraine, and a lot of the work that's being done in that space, what are the main ways we are able to have increased casualty survival on the battlefield? And like Dr. Walker said, it really comes down to blood. But at the same time, our blood banking, our logistic capabilities in Lisco is detrimented by the lack of air superiority, the length of time between taking a casualty from the point of injury to a roll to or a surgical capability. And the time it takes to do that really is the pre-hospital blood. What can we do to prolong survival? And it's blood. And unfortunately, with the casualty rates that they've been seeing in the Ukraine, we can go all the way back to World War II when we published our review in the Journal of Trauma in 2023, looking at a lot of these battles, Operation Overlord for D-Day, and some of the battles in the Indo-Pacific. We've had thousands of casualties per day, and the blood demand just won't keep up. And then we're looking at the Office of the Joint Staff Surgeon with the requirements of at least 8 units of blood per casualty with severe injuries. We're looking at hundreds of thousands of casualties potentially with 8 units of blood for 20% of those casualties. It's just infeasible for us with the current blood banking system to keep up. And I think that's what really framed our question and our hypothesis to see what are some alternatives to our current modern day blood banking system. And I think John and I, and with Dr. Walker, what are some alternatives? And unfortunately, the work in the engineered red blood cells and some of these hemoglobin oxygen-based carriers haven't come to fruition yet. So we're looking at some alternatives, and that kind of lets the deep dive into this historical aspect into deceased donor blood, formerly known as cadaver blood. We kind of like the word deceased donor because it plays into some of the current day modern standards from organ donation. So
yeah, that makes absolute sense. And I think you're absolutely right. Like, especially even if we just looked at historically what casualties were World War II, superimpose that on modern times, it is going to be bad, right? Just the denial of airspace, the air threats, the EW threats, et cetera, et cetera. I mean, we can barely keep up when it comes to just civilian blood donation, and we have no of those worries, right? So, we're going to have to figure something out, right? So, like I mentioned in the last podcast, the real question was, is this any better than just sailing? And we already know sailing ain't great, but it's not particularly harmful. Like, nobody's had an allergic reaction to water yet. Is this going to be any better?
Well, I mean, I would venture to also say that, like, I feel that just giving saline itself could also be detrimental, because you can certainly have like the effect of delusional coagulopathy, right? Which is not something that you want in a trauma patient. So to simply say like giving salt water to a trauma patient is harmless, I think is also kind of a necessarily moving in the right direction. Yeah,
John,
and so
perhaps you could comment on some of the papers you referenced in your review, just published in transfusion, from the a lot of, I think the really interesting ones are from the former Soviet Union. They're Russian physicians, but also Ukrainian. And many of them, and some of these were even published in English. And to y'all's credit, y'all traced down some of the Russian translated articles, but they wrote about this. They expressed doubt and skepticism, and they did it in preclinical models, and they used it clinically. So, John, maybe you could give some insights from those lessons as well.
yeah, absolutely. So, as Dr. Walker mentioned already, the USSR, when they first started off with this back in the 1930s, they initially did a cadaver dog model, and they demonstrated that they could successfully transfuse from a deceased dog to a living dog without much harmful effects. It took them some time to then make like that leap towards seeing whether or not this could work in a human, right? And from documentation and literature, it seems that like the first human subject that was transfused was, a young individual that tried to commit suicide, and it had a pretty significant, loss of blood. And at the hospital that they did not have this was prior to modern day blood banking standards. So they didn't have any available bloods or available donors available. Uh, but what they did have was a deceased individual, and out of like a desperation, they transfused the blood from the deceased individual to the suicide patient, and that individual lived. And so then that led them down to this, research pathway of, can we do, deceased donor blood transfusions from deceased individuals? Um, and the results are actually fascinating, because you start to realize that the USSR published this pretty much right until the fall of the USSR in the 80s. And so this is not something that has only been done in a very short period of time out of relative desperation, as what one might anticipate. But it seems that in quite a few hospitals in the USSR, they actually transfuse in some cases, pretty large volumes, right? We found for one individual, they would transfuse up to 6.2 liters of deceased donor blood because they needed it. And then we also found too in our research that it wasn't just a small, few amount of individuals that were transfused. We found, and we believe this is probably a conservative estimate, 4,000 recorded cases, 4,000 individuals, that is, that receive deceased donor blood. And then on top of that too, we were curious as to like the question of whether or not some of these patients were trauma patients, right? And because that's specifically pertinent to like a military setting, and we actually found that 35% of the 4,000 that we identified were actually trauma patients. And so the fact that historically, the evidence suggests that at least 1,300 to 1,400 trauma patients have been transfused successfully with deceased donor blood, with pretty low side effect profile. From these studies ranging from 0.5 to 2.7% of reactions. And then the more severe reactions were more linked to like errors in technique, such as transfusing blood that was not matched appropriately, or blood that or like air embolism or things of that sort, rather than like the actual act of transfusing the deceased donor blood causing significant harm. Y- Tends would basically suggest to us that such a thing is feasible, and that there probably is a population or an identifiable deceased individual from combat that we could probably that we would need to do more research on to figure out what is like the ideal deceased donor, basically, that will work in such a trauma setting.
Like a transfusion reaction, or an infection, or an air
Mm.
embolism because somebody's messed up. Yep, absolutely makes sense. And 7% would be pretty high compared to modern day
2.7. 2.7.
Oh, I'm sorry, 2.7.
Yeah,
All right, well, that's about in line, I guess, with modern transfusion type reactions. Like, so what other, did they say any other kind of reactions or responses other than he lived?
That part gets a little bit tricky because a lot of these studies were done prior to the 80s, right? And that basically lends to us saying that because it's been documented that individuals have been successfully transfused, but we don't necessarily know the long-term clinical outcomes, or you know aside from like these individuals lived, right? So the suggestions from these is that more work certainly needs to be done.
Mhm. Yeah, it absolutely makes sense. So, um, so you started doing the foundational research. You did your background information, like, hey, like, we're not Frankenstein here coming up with this random stuff to test. Like, somebody's tried to do this, and I think just like any good scientific study or research, you take what somebody's already done, and your first step is finding out, like, is this true or did they just make it up? And if it's true, then it should be reproducible, right? Um, so, I guess how did you decide or design, like, what is the first steps in doing some kind of actual foundational research for this?
Yeah, so I think the next our first that data that we presented last spring was at least in our foreseen models was really just exploratory. And so what we've got planned upcoming in the next few months is a dedicated protocol where we look at least it's I think there's all sorts of variables to take into account, but at least an exsanguination model, so you have the opportunity for that inflammatory response and some of the evil humors to be produced, right, and be present in the blood, and just really kind of better characterize and wait variable periods of time, measure the blood in terms of its its chemistry and blood gas, also looking at how well it clots and sort of that viscoelastic type of testing. I think we'll be very keen to your point on some of the infectious questions. And John, I believe it was up to 6 hours that's been described as what was thought to be a safe window to collect blood, in these kind of postmortem periods and dealing with the breakdown of the gut and the increased risk of infection. At least to start, and then working with some collaborators. I think as organ donation has since the deceased donor blood donation was done, but as that has really advanced, are there opportunities in some of these certainly the organ donors who either don't proceed to donation or we're able to collect some blood from them. What can we learn? I think that's really our focus now, is that research question. The other thing is you think about all the ways that blood can be, modified post donation. It could be irradiated, it can be leukoreduced. What are some of the other things that we can do to kind of wash the blood, get the evil humors out, but keep those good factors, the red blood cells, the clotting factors. Acknowledging they may not be 100%, but they may be better than I think your point to a saline or something like that. Can we help? Can we give TXA? Can we give other things that can help those work better? The platelets as well, and then how that can inform our shortages. Because I think ultimately, if folks get into a situation where they're running out of blood, that's I think people are gonna, understandable that the people have some questions about this and some skepticism, and there's all sorts of ethical challenges. So I think that's our perspective, is to try and understand it in as best a way we can, to how that might inform future decisions.
Yeah, and I think, at least just my opinion at the moment is, I don't know. This seems kind of weird. I need to know that I'm actually doing a positive thing, just not doing a thing, right? At least right now. And giving a patient back blood that's already been exsanguinated is not new at all. There's a cell salvage systems to take blood out of chest tubes, etc., and they spin that down. I've never done it, so I'm just imagining they spin this down, they add some stuff, they take some stuff away, and then they infuse it back, just to reduce blood needed to be transfused. I guess when it comes to testing, would you be doing just like the full blood bank kind of full court press to find out what it is, or is there specific things that you want to look at?
Yeah, I think in the context of research, absolutely trying to understand as much as we can. That's another big need, and Colonel Jen Gurney, director of JTS, has written a lot about this, and the need to understand, from a point of care perspective, some of the, we do have some capabilities. We have an Eldon card, right? But there's no really good, robust point of care, infectious disease testing, certainly titer testing. But I think, those needs are, very much exist right now from a research perspective. And I think we could see those going, hand in hand with this type of work. Ultimately about expanding, blood donor pool. There's groups working on that cell salvage out of transfusion. That's really, really interesting and compelling. There's groups working on, how can we change, red blood cells that might be A or B to O, and increase the donor pool there. So I think to kind of emphasize what many have said, in this podcast and others, all of this type of work, we would hope would synergize, that, we can try and find out as much as we can.
Yeah. And I think ultimately it could be just thought of as the same as any other organ donation. It's just a matter of, once we get the numbers and we understand, okay, this population with these parameters that are true, this is what the product we get at the end, and this is kind of what niche it kind of fits into to get the patient from A to B or whatever. The last thing you need is somebody like me running around the battlefield, just like poking guys and sucking their blood out and giving it back because that's red. He needs more red. I'm going to do that.
Definitely. The first do no harm. That said, I've just, the know-how, the ingenuity, of all sorts of folks, particularly in this, the pre-hospital space, and thinking about the prolonged field care challenge. I think we've got to lean into that, and all of your expertise.
my expertise could fill note cards, right? So, I guess going forward, you're obviously, like, you've done the preliminary data collection, right? Like, I guess, how are you going to test this? You mentioned like a hemorrhagic model. Okay. So I guess what parameters would you want to set? We talked about, what labs that you'd want to get, but I guess how would you recreate that kind of patient?
Yeah, a great question. I think if we take it to that preclinical space, one, just characterizing, and we really don't do much in terms of canine models, very understandably now. It's a lot of porcine work. What's interesting though is that the pigs are much more hypercoagulable. They clot much easier as kind of prey animals than humans do. So much of this, at least large animal translational work, is being done in non-human primates. So acknowledging, every model is wrong, some are useful, but essentially characterizing, and kind of replicating some of what was described in that, in particular that Soviet literature that John and Mason have written about. But then also I think we could envision, different, injury models and mechanisms of death, but then also looking at, doing the actual, deceased donor transfusion in another animal. We could also look at positive control. So, what happens in the worst case, right? Is there, could we have pathogens, in that blood that we give, right? Put some E. coli or something in there, allow for a really long period of time. Could we purposely do mismatched donors just to characterize, what happens in the worst case, so we can understand that? Of course, doing that, and sedated, very, ethical approach. But just understanding that worst case, the biology of it, so that we can have a sense of the kind of left and right limits of when things might be safe. And then I think, from there, what are some things we could reasonably do to take the bad stuff out and preserve the good stuff, or even put good stuff in. And I think this gets to, is there, how can we make blood better? It seems kind of tongue in cheek to say, but that is part of you look at science today and how we can both understand things and modulate things. But what we can do, ultimately help buy more time, and or increase supplies and logistics, all these sorts of things.
Yeah, of course. So, you start off with the porcine model. Then you at least mentioned, so after you get that preliminary data, comparing apples to apples, this is what happens. We can presume what's going to happen. Then you move on to non-human primates, if I gathered that correctly.
Perhaps, I mean, and Mason mentioned, the transplant space, and if we just use them as an example, particularly some of these donors that, may not perceive a brain death. And so we have to wait for, their heart to stop for them to be donors. And if that doesn't happen after, a certain period of time, or their organs are donated, what we can learn from them. But, some of these, newer techniques for organ transplant, for example, some of the xenografts from pigs and others, those have been, donated into, brain dead recipients. And so if we were to, really, look at, ways we could collaborate with folks, those types of experiments would be, I think, very informative, and opportunities, and ultimately, this would definitely apply in the military in these large scale, potential combat situations. But mass casualty events, on the civilian side, and how we can expand the donor pool in other contexts as well.
Yeah, absolutely. So another aspect, which not at all your responsibility to find out the answer, is kind of the ethical one, and there's no way to get around it. And ultimately, I can easily foresee, we find out the research is great. Like, turns out it's actually the same thing. It's just from somebody who is expired. Now the weight is now on the medic. I have a patient who I have somehow managed to get to the decision. This is a palliative care patient. I have another patient that could really use that blood, and I have none to give. This how is anybody even, obviously people are thinking, but is the thought process going beyond, wow, that would really suck? From the palliative care aspect, me draining somebody's blood, is that still kind of in lines with a good death? The whole point of palliative care.
Yeah, it's super important question, super heavy question. I think we can learn again from the transplant community here. Ultimately, and there's one of the papers, I think, John, was, I can't recall the author, but it's a really, really beautiful paper. But the first line is it talks about how death is not an instantaneous process. And while the organism, as we understand it, might have passed away, there's still organs, that are alive and that we can transplant. There's still cells that are alive. And our understanding of death ultimately has evolved, as science has evolved. But I think for some of these ethical questions, right? Because you can envision, like, okay, because someone's expectant, can we then take their blood? And I think in the transplant realm, there are there's donation after brain death, which is just lack of blood flow to the brain, and as we understand it, that is a circumstance from which that person cannot recover and cannot survive, and in fact we can pronounce them as having died. And then that gives time to look at their organs and assess their function, and find good matches for donors. And then that's a whole process, right? You bring the teams together and you have plans in place, and there's a huge infrastructure surrounding that. The donation after circulatory death, where the donor is allowed to very kind of peaceably allowed for their heart to stop for a period of time, which is oftentimes legally defined, or comes to be agreed upon, that we say, okay, we think that this person cannot be resuscitated, and allow them to proceed to donation. But there's different standards in different states, different standards in different countries. Some countries don't do, for example, heart donation after circulatory death, which if you think about it, the very organ by which you were declared dead is restarted, and in fact it's restarted so well that it's donated to someone else to save their life. That was actually the first heart transplant, which was done in South Africa, was done in that way. But having boundaries, and I think your point, Dennis, what's important with this research and understanding biology is thinking about the ethics. Honestly, I think that's, any of us in the medical field, that's the thing we want to think about the least amount, right? We just want to save lives, but unfortunately, we think there's even now, right, there's circumstances where we can't save everyone, and so how do we best approach that? looking at the individual going through that, but also the kind of bigger picture, greater good. And then if it's all, in a military perspective in support of the mission, um, and how that might look as well. So yeah, definitely. And I know you've had folks, talking about that and thinking about that, and that'll be really important in all this as well.
Yeah. Again, like not at all your responsibility to have the answer, but that's always something that, once you've given the power to somebody, like, this is positive. The flip side of that is you're going to have to do something potentially negative to somebody in order to do that. And, will there be a moral injury afterwards? I think there was one thing that kind of stuck with me with my last podcast is, the idea of like the road to hell is paved with good intentions. You make one ethical decision now that was like, and pretty soon it starts getting really easy. Not at all that I think is the situation with this. We're just trying to figure out what actually happens, from what I gather. But I think it's always something super important, because once the power has been given, even to a medic who doesn't have nearly the experience or education or logistical and everything else support, they're still going to do it if they think I can save my friend by doing it. So yeah, I think that's the moral argument is always something that should at least be talked about.
For sure. And I think we agree 100%. And I think the enabling the both the knowledge, the tools, the training, any of these things, the technologies, right, that can enable better care. We can also think about the moral injury to any medical provider or personnel team, right, where they have that casualty there in front of them, and if they just had more blood or they just had the right thing, and but they don't, and then they aren't able to save that life, what that does, from a both moral injury perspective, what that does for morale, all of these sorts of things. Colonel Gurney, and I think we're learning a lot. Mason mentioned, our Ukrainian, colleagues in all of this, but Colonel Gurney has a fantastic talk where we talk about PTSD or PTS and post traumatic stress, but what are some ways we can look at making that post traumatic strength, acknowledging that these will be very difficult situations, but how we can better enable folks to be better prepared and ultimately trying to have better outcomes.
Like mentioned, you're moving forward with the research. Is there any kind of highlights or things that you want to kind of put out there?
Mason John.
I think just kind of going off our ethical conversation, Dennis, we kind of mentioned it before when we were just chatting quickly, but us being in the military, we're in a unique situation where we form bonds between our fellow service members. And I think, if a patient or a fellow service member does expire and they have the ability to save one of their other fellow service members by, donating their blood after they had died, I think a majority, or if not, most would say, please do so. Please help me save one of my friends, or, who many, end up considering their family at that point. So I think that is something that is an important aspect we need to continue to discuss. And, it's just like normal organ donation at that point, So I think that's a conversation you should have. And I think, me and, Dr. Walker and us coming from West Point and, going to, the Uniformed Services University, we build these bonds with a lot of our classmates and our fellow service members. And I think, if I died, I would say I would gladly, have my blood donated after my death to save one of my friends, or one of those people that I consider my family. So I think that's something that we should, everybody, I think in the military has a similar point of view on.
Yeah. I do want to like also bring up the fact that us at the Battlefield Shock and Awareness Court Lab, we're also just, the deceased donor blood is a component of like the overall research that we're doing. And we're also looking into, better understanding the blood supply limitations along with, the complete capabilities of like a walking blood bank or the existing, conventional blood supply, and all modalities basically of like resuscitation, or even like logistics, raw materials, surgical capabilities, when it comes to LISCO. And, so this is like a piece of our research, but it's important to like get a better understanding. There's a lot of work going towards finding out what the requirements are, but there needs to be like an understanding of, yes, these might be the requirements, but do those requirements actually meet the casualty rates that we're actually going to experience in the LISCO scenario? And that the better understanding of those factors, will probably be a big driver towards a lot of decisions that we end up making.
Well, awesome. I really appreciate you guys jumping on and kind of walking me through things.
Thanks, Des. Really appreciate it. We love the work you do. Really appreciate it. And we keen for anyone out there that's interested in this. And we're always looking for folks to collaborate and understand these kinds of things as much as we can while we have this time, relatively speaking.
Awesome. All right. Thank you. That's it for today's podcast. Make sure to go to our website, www.prolongedfieldcare.org. Check out our free downloads and a ton of other helpful information. Grab a bag of our fresh roasted PFC coffee, links in the description below, and stay on the bleeding edge of combat and austere medicine. This is Dennis for the PFC podcast. Out.